Hi, this lecture is on data engineering and we would be exploring Databricks. This will also help in the exam 203 Data Engineering on Microsoft Azure. What we will do is that we'll run through the concepts, we'll do the labs in which we'll ingest data, we'll query data in files, we'll analyze data in a data frame, we'll aggregate and group data in a data frame, we'll query data using Spark SQL, and we will visualize data with Spark. So the Databricks, one of the most important components is the Apache Spark cluster. Each Spark cluster has a driver node to coordinate processing jobs and one or more worker nodes on which the processing occurs. The Databricks file system. The cluster node has its own local file system on which operating system and other node specific files are stored. And the nodes in a cluster have access to a shared distributed file system in which they can access and operate on data files. The Databricks file system enables us to mount cloud storage. Notebooks. So, one of the most common ways for data analysts, data scientists, data engineers, and developers to work with Spark is to write code in notebooks. This provides an interactive environment in which you can write text, you can add graphics in markdown format, and you can run code also in an interactive manner. The Hive metastore. Hive is an open source technology used to define a relational abstraction layer of tables or file based data. The tables can then be queried using SQL syntax. The table definitions and the details of the file system locations on which they are based is stored in the metastore for a Spark cluster. The Hive metastore is created for each cluster when it's created, but we can configure a cluster to use an existing external metastore if necessary. The Delta Lake builds on the relational table schema abstraction over files in the data lake to add support for SQL semantics commonly found in relational database systems. The capabilities provided by Delta Lake include transaction logging, data type constraints, and the ability to incorporate streaming data into a relational table. SQL warehouses are relational compute resources with endpoints that enable client applications to connect to an Azure Databricks workspace and use SQL to work with data in tables. The results of SQL queries can then be used to create data visualizations and dashboards to support business analytics and decision making. SQL warehouses are only available in premium tier of Azure Databricks workspaces. Let's jump in and see what we have done with the lab. So, I have already created a Databricks workspace and you can see it here. And I have gone ahead and created a cluster in the workspace. And I created a single node cluster and my node type was a standard DS3v2. Note here that the control plane or the data that is controlling is within Databricks, but the actual data is in Azure. So if I go into the Azure, when we create the cluster, another resource group is had been created before, and this has the machine, the virtual machine which we talked of, and you can see that this is also a standard DS3v2 machine. So this is in another resource group and it is created via the main resource group. So let's jump in and go and work with a notebook where we analyze file-based data using Spark. So first what we are doing here is that we are getting the files 2019.csv, 2020.csv, and 2021.csv in the DBFS data folder. This is how we are doing a wget and we are getting the data. We are querying the files by using data/start.csv and we are reading the files here. Here the data that you see, the header information is not there. As you can see, it has got C0, C1, C2 and till C8. So what we do is that we define a stock type, which is, and here what we are doing is that we are defining a schema with the sales order number, sales order line number, order date, customer name, email, item, quantity, unit price and tax. And here we are loading the data. We are printing the schema here, analyzing data in a data frame. So what we do here is that we are selecting the customer name and email. We are counting the customers. We are getting a distinct of the customers count and we are also displaying the distinct customers here. So these are being counted. So we are seeing that there are around 327, 32,000 customers and 12,000 of them are distinct and we are displaying those distinct customers. We can also do a select of the customer name and email and we can filter it with a with a product which is road to 50 red 52. And then we can print the customers, we can print the distinct customers count and also the distinct customers. So here we are having 133 customers for that filtered data set and the distinct customers are also 133. How we are aggregating and grouping the data in the data frame. We are selecting the item and the quantity. We are grouping by the item and then we are summing it. Let's try another aggregation. Here what we are doing is that we are selecting the year, the order date. We are grouping by the year. We are counting it and then we are ordering it by the year. So here, as you can see, we are getting per year what is the number of items there. We are querying the data using Spark SQL. So we have got the data, the Spark data frame, and here what we are doing is that we are creating a temporary view known as a sales order. And this sales order is then we can query using the spark.sql. So df.create or replace temp view sales order. It is creating a view called the sales order and then we can do a SQL on top of it. We can run SQL code in a cell and now what we are doing is that we are getting the order year. We are getting the gross revenue by multiplying the unit price by the quantity and adding the tax. We are grouping by the year of the order date and we are ordering it by order year. In Spark, what we are doing is that we can also visualize the data. The visualization of the data can be done with standard Python libraries such as matplotlib as well as cbon. Only thing is that you have to convert the Spark data frame into a pandas data frame and this would help us in visualization very easily. So we are again selecting the sales order. We are using a SQL query. Also, we are getting the order year. We are getting the gross revenue. We are grouping it by the year and ordering it by the order year. To visualize the data as a chart, we are using the Python matplotlib library. But here, one thing to note is that the matplotlib requires a pandas data frame, not a Spark one. So that's why we are converting the Spark data frame to a pandas one. And then we are using a bar plot. Similarly, we are also using a bar plot here. That is what we are getting out here. We can customize the chart by using line styles, different line styles. A figure can contain different plots. The first plot is a bar plot and the second plot is a pie chart. And this is standard matplotlib programming, and we can do these things also here. We can use the Seaborn library, which is another data visualization library, and this abstracts the complexity of matplotlib, and this can also be used in Spark. We are creating a bar plot here. We are creating a bar chart. We are creating a line plot here. So what we have done in this total session is that we have shown the concepts of Azure Databricks, what are the different components. We have analyzed a file using Spark, Pandas Spark libraries, and also, Apache Spark libraries, and also the data visualization using Matplotlib and Seaborn. Hope you liked the lecture. Thank you. Bye.